Hello everyone, I am Jagat and in this video I will talking about Hadoop, its architecture, and we will also see an example of MapReduce, which is a word count. So what is Hadoop? Hadoop is an open source framework that allows you to store and process big data in a distributed environment across several clusters of computer using simple programming models. It is designed to scale up from single server to thousands of machines, each offering local computation and storage. So, what is big data? Big data is a collection of large data sets that cannot be processed using traditional computing techniques. So, size doesn't really define big data. The amount of data considered huge now may not be so in the future because technology keeps on improving, and you may see that more data storage is relatively cheaper in the future, like it was like way back. So 1 TB was considered huge data. Now 1 TB is not really that huge. So how is data generated? So there are three main sources of data. There are more than this, but there are three main sources. First one is people data, which is data from social media sites, research paper, and stuff, the data which people produce. So machine data is data which machines produce. They can be sensor data like temperature sensors and other output from machines. So the third one is organization data. This is the data produced by companies to maybe like run the company. You need employee database and stuff like that. So what are the types of data? So there are three types of data. Structured, which is having like a fixed schema like RDBMS, where you have data in form of tables and you have predefined columns. So there is a fixed schema. So unstructured data is like what people produce is usually unstructured data. So your social media data, etc., are all unstructured because they don't have a predefined schema. So semi-structured data is something like your XML files and JSON files. They are partly structured. So how do you handle big data? So traditionally, a single system used to handle all the requests of all the clients. Now this is okay for less demanding applications, but as the number of clients increased and as your service complexity increases, the traditional approach did not work. So in 2004, Google produced a MapReduce white paper. So in their paper, they introduced an algorithm which divided tasks into small parts, distributed the task to different systems, and the work which was produced by these different systems were later combined together to form a single application. So, for example, you can consider a task to make a blogging site. So traditionally, the approach was that all the work, whatever was required to make the site, was done by one system. So one group. So using MapReduce, what you would do is you assign different tasks to different teams. Like UI UX design is given to one team, data collection to another, marketing and testing to different teams, and so on. So all these work are later combined together, and then this forms the complete blogging site. So it is not like the traditional approach doesn't work, it's just lesser efficient. Obviously, working with different teams will uh, like increase parallelism and increase your throughput and efficiency. So Hadoop was a project which was introduced in 2006. It used Google's idea to develop an open source project, and it could handle huge data efficiently. So the first version of Hadoop 1.0, had no yarn. So I will explain about yarn later. So yarn is the abbreviation for yet another resource negotiator. So yarn actually in Hadoop 2.0 it was introduced. So yarn takes over the job of resource management in the Hadoop system. So, which Yarn was not there in 1.0, where MapReduce had to do all the job which Yarn was doing. But in Hadoop 2.0, the resource management task of Hadoop was given to Yarn rather than to MapReduce. So this made Hadoop even more scalable, and it could be used in non-map reduce operations also. So in Hadoop 1.0, the Hadoop was limited to map reduce applications only. So here you can see the Hadoop 2.0 architecture. So this is called a layer diagram actually. So in a layer diagram, the upper levels like Hive, Pig and all, they use the services provided by the lower layers like HDFS. So HDFS provides service to Yarn, Yarn provides service to MapReduce, and so on. So what is HDFS? HDFS stands for Hadoop Distributed File System. So HDFS is a distributed file system which was designed to run on commodity hardware. What is commodity hardware? If you ask me, then it means that the system is not specialized and it is actually inexpensive. Like not the it doesn't have huge data centers like we have in companies. You can run it. It was meant to run on like non-commercial hardware. You can say that way. So since HDFS allowed replication, which I will talk about later, it is highly fault tolerant and it is suitable for applications that have large data sets. So HDFS has a master-slave architecture. What do you mean by master-slave architecture? Master-slave architecture in the sense there is one master, which is in this case name node, which manages the working of the slave. In this case, it is data node. So what is this name node and data node? We shall see that. So name node executes namespace operations like opening, closing, and renaming files and directories, and it determines the mapping of blocks to data nodes. So as we know, or maybe you don't know, so HDFS uses a hierarchical file structure similar to most I'm sorry, Linux based file system. So it uses hierarchical file system. What do you mean by hierarchical file system? In the sense it uses like a tree structure where the leaf nodes are either empty directories or files, and the intermediate nodes are directories, and there is a root directory which is the root of the tree. So data nodes are responsible for the read and write requests from the file system's clients, block creation, deletion, and replication upon instruction from the name node. So as I had told earlier, HDFS keeps replication of its files, and all the files in HDFS are divided into blocks of fixed size. So these individual blocks are then replicated. Uh, so the default number of times replication happens is 3, but you can change that in the Hadoop file, hdfs site.xml. So in that particular file in Hadoop, you can change the configurations of HDFS, including replication. So basically, name node manages the file system namespace and regulates access to files by clients, and data node manages the storage which is attached to these nodes that the data node runs on. So name node, actually there is only one name node for the whole cluster, whereas there are individual data nodes for each node in a cluster. So each block of a HDFS file is stored in a data node, and the name node manages these blocks. So here you can see the HDFS architecture depicting the role of name node and data nodes. So HDFS is built using the Java language. So as you can see, the next layer in the Hadoop architecture is yarn. So now I will explain about yarn. So as I mentioned earlier, yarn opens up Hadoop to other type of distributed applications beyond MapReduce. So in Hadoop 1.0, yarn did not exist, and the applications were limited to MapReduce applications only. So Yarn enabled us to perform operations as per the requirement using tools like Spark, Hive, HBase, and others. Apart from resource management, Yarn also performs job scheduling. Yarn performs all processing activities by allocating resources and scheduling tasks. So the next layer in the Hadoop architecture is MapReduce. We will briefly explain about MapReduce now. So later I will be explaining MapReduce with example in detail. So MapReduce is an algorithm to distribute work. Map is a process where the input data is processed, and it creates chunks of data. So in the reduce stage, we process the data which comes from the mapper, and after processing the data, it produces a new set of output. So if you've not understood this, don't worry about it. We will talk about it in detail later. So in the architecture, you might have seen something like Storm, Spark, Flink. All these are for real-time and in-memory processing. So what this means is that you take computation to the data, like it's like in situ processing, it's called in situ processing, and not the other way around. That is, you don't bring data to the computation. So Hive is for SQL-like queries, which is built on top of MapReduce. So MapReduce is relatively more complex to write codes on. So Hive simplifies that part of coding. So HBase is for NoSQL. So NoSQL in the sense like there's no fixed schema. It's for unstructured data. And Pig is for data flow scripting. Zookeeper is for synchronization, configuration of everything, and it ensures high availability. and giraffe is for visualization of data, like the name suggests, it's for like graphs. So Cassandra is a NoSQL database for transactions, and MongoDB is also used as a NoSQL database. So now we shall look deeper into reduce using an example of word count. So in MapReduce, there are usually three stages. First one is mapper, second one shuffle and sort, third one is reducer. So mapper processes input text, shuffle and sort, shuffle each word such that each word comes under one block or token. What are tokens we shall soon see, and after doing that it sorts the keys, and reducer adds all the values corresponding to a particular word. So I will be explaining these. If you don't understand it yet, don't worry about it. So step 0, file is stored in HDFS. So as you know, a file is divided into fixed size blocks, and these blocks are stored in a hierarchical manner in HDFS. And also replication is done, but that one we won't be showing here for simplicity purpose. So let's say that block A of the file had the sentence, my apple is red and my rose is blue. Block B had, you are the apple of my eye, and so on. So what the mapping phase does is it counts first of all, counts how many times my has come. So as you can see in the sentence, my apple is red and my rose is blue, the word my has come two times. So my comma my is mapped two times. So again, apple is present in the sentence one time, and so on. All the words in the sentence are mapped accordingly. So similarly in block B also we do the same thing which we did in block A. So all the words are mapped to the number 1. It just shows that U is counted one time. So here my was counted two times. So that's what it does. So step 2 is sort and shuffle. So what happens in sort and shuffle is that in the map phase you had map the individual words. So in shuffle phase, you keep the same word in the same block. So for example, here the block size is actually 3. So we shuffle the words in such a way that the same word comes in the same blocks. So as you can see, all the apple mappings are in block 1. All the U mapping is in block 1. All the E's mappings are in block 2. And rose is in block 3, red is in block 3. So here in shuffle, you make sure that all the words come in the same block, like the same word comes in the same block. For example, all the apple mappings should come in the same block. So next is sorting. So sorting in the sense you actually have to like make sure that all the apples come together, all the like the same words, it should just come together. That is sorting. So to give you an example of what is unsorted, if say let's say here apple came first, then you came, then apple mapping came again, then it would have been shuffled, but it would not have been sorted. So sorted means the apple should come together. So next step is the reduce step. So here what we do is that all the blocks, like say here in block 1 you got apple 2 times. So you in the reduce step, apple comma 2 we will write because apple came 2 times. So let us also assume that Apple came completely in some other block also. Let's say block 3 had apple comma 1, apple comma 1 instead of rose and red. Then in that case, apple comma 2 will be there in block 3 also. So what reducer does is that it combines all the outputs from all the blocks which are here. You can say it as blocks or tokens, and then it sums up all the counts, and at the end you have the total count of that particular word. So it's the final output of your word count algorithm. So this is how MapReduce is used to count the number of to count the frequency of words occurring in a text file. So now we shall also see the program of how to implement this in Hadoop. So here I'm assuming that you are somewhat familiar with Java programming language. So these are all the inputs, modules which are necessary for our program. So first I will be explaining the program, then we shall see how we can actually execute this program. So first we shall see how the mapping phase of MapReduced is coded. So as you can see, this is my class in which I'll be writing the mapper function. So public static class map extends mapper. So extend here means inheritance. So our map class which we are writing inherits a few like all the modules and variables which are defined in the predefined mapper class which we import. So here you can see a few things which are enclosed in angular brackets. So these are nothing but the inputs to the mapper function and the output of the mapper function. So the input is of the form file offset maps to sentence. So file offset is like it is a number which represents like where a particular line is in a file. So it is a file offset. So that is of the type long writable. So input is the value of input is sentence, which is of type text, and output is of the form word maps to 1 plus. So here 1 plus represents like 1 any number of times. Like if you're familiar with regular expression, you should know what plus is. So it can be word is mapped to one number of time, or more than one number of time. Like for example, red can appear in your sentence 1 time or 2 times or so on, any number of time. So it's of that type. So word is of type text and 1 plus is of type int writable. So in the function map, you can see that there is something called context. So context is an object through which our mapper can interact with the rest of the Hadoop system. Here, actually, in our case, context holds the count, the word count, which will be our output of the mapper class. So it is actually 1, but yeah. And of course, key is, as we know, key is in our case the file offset, and value is the sentence which was present in our file. So first thing we do is the value what was there, the sentence which we receive as input, we will be converting it from a text file, a text data type to string data type, because it is easier to handle strings in Java language. So then we call a tokenizer object, which is a object of class string tokenizer, which is already defined, and we actually imported that, and we run this tokenizer on the input line. So while tokenizer has more tokens, so while there are tokens which exists, we have to do the following steps in a loop. So first we have to take the next token. So this is for picking the next token. So context dot write, here we write to the our context which we took over here. So to our context we write corresponding to our value, we write 1. So it was like if you remember, writing apple comma 1, if you remember our example. So next we will be seeing how reducing phase works. So uh, similar to mapper, reducer inherits modules and variables from the reducer class, and its input is of the form word is mapped to 1 plus, and output is of the form word is to count. So word is to count in the sense it's the final outputs. So like for example, in our example which we saw, apple was mapped to 2 because apple was there in our file 2 times. So that should be our final output which we get from reducer, and input here is the whatever is the output of our mapping phase. The reducer phase takes the output of the mapper phase as its own input. So in reduce step, as you, if you can remember, we take actually sum all the values corresponding to a particular word and give it as output. So all the mappings which we obtained from the mapping phase, we take those, group them, and then we add all the counts together and give the final count as the output. So initially our sum will be 0. So before that, similar to the mapping phase, this key corresponds to this particular input, and this iterable values corresponds to this input. This input is corresponded by this no, I'm sorry. Output is the one which our function outputs. So context will contain the final output after we finish our computation. So how do we do this? So the input, this thing 1 plus, is in the form of a iterable. So we iterate through all the values corresponding to a particular key or to a word in this case. So corresponding to a particular key, we iterate through all the values and we keep on adding those. So at the end, we write the particular value sum which we calculated into our context. So now we shall see how to write the main function. So the first line here, as you can see, it is for setting the configuration of MapReduce to run in Hadoop. So the second line is for specifying the name of the job. The third line is to specify name of the program class, similarly name of mapper class, name of reducer class, and then in these two lines we are saying the data types of the input and output of mapper and reducer. So here this function is specifying how mapper reads input, what unit of work it is doing. So here text input format it is, which means that our mapper is going to read line at a line, line by line from the input text. So while executing our program, actually we give the arguments. So this arg s of 1 corresponds to the first argument where we will be specifying our output path. That is where the context variable should be written corresponding to the word. That is the final output of our word count program. It will be present in this particular output path at the end. So similarly, we define the input path, and this particular line deletes the output path automatically from HDFS once done, so that we don't have to delete it explicitly. So we exit the program if the job is completed, then we exit the program. If not completed, then we don't exit. So now we shall actually execute this and see our output of word count. So for executing our word count program, I will be using the Eclipse development environment. So that is easily available online, and that is a free development kit. So we shall launch Eclipse. So we create a new Java project. Give the name whatever you want. I'll just give my own name, and I'll be using, so by default Eclipse uses the latest GRE version, which in my case is Java SE 11. So we have to use Java SE 1.8 for Hadoop. So now click on finish. This should set up your project. Okay, so now we must create a new Java file. So for that, go to file, new, class. So name we will give word count, and now finish. So as you can see over here, our word count.java file has been created. So now I will just copy paste the code which I had explained earlier. Okay, so here you can see that it is showing many errors, that all these libraries that we are importing, they cannot be resolved. So this is because we need to import a few packages, or I can say jar files to make sure that Eclipse recognizes all of these. So to import the external jar file, first right click on your project name. You should get an option called build path over here. So over here, go for configure build path, this option over here. So here you should be able to see the libraries option. Go for the libraries option, and here you can see add external jars. So click on that. So here you have to browse to your wherever your Hadoop has been installed. So for me it was in downloads and Hadoop 3.3.0. So inside your Hadoop home, you will see your directory share, Hadoop, common, and here just add all of these jar files. Open. Okay, it was not working because I have selected a directory as well. So don't select the directory, select all the jar files and now open. So this, as you can see, it has added all the jar files. Now again, go to Hadoop, HDFS, and we can just copy all the jar files. And just to be safe, let's just uh, do it from all the tools. Let's just import everything. Okay, so next you can apply and close. So now as you can see, the import errors are gone. Now let's see what is this error. So this error is because we have not imported the long writable part. So there are more errors over here. Okay, so it looks like I had forgotten to import a few modules. So I have imported those modules now. So as you can see now we don't have any errors. So now that our program is set up, now we must start all of our Hadoop daemons. To do so, I will first open a terminal window. So here we have to give the command start all.sh. So this will automatically, this is a shell script which will automatically run all of your Hadoop daemons. So this, as it says, it should take about 10 seconds. Okay, now that all of our daemons are running, now we can. Okay, so now we must export this particular program as a jar file. So to do that, I will first expand my project, expand src. So here you should, I'm sorry. Yeah, so here you should see your program. So now we will export the whole project as a jar file. So to do that, right click on your project, click on export, click on Java jar file, next. So here check on all these three options. So now you can choose the location of the jar file. That is where your jar file uh, you want it to be stored. So I will store it under Word. I'll just um, I'll just store it right here in the Eclipse workspace directory as word count.jar. Okay, jar was already there, so save. Now we can finish it, and it should save in that particular location. So now that our jar file has been successfully created, we must now create the input directory where our input file will be present. So our input file must be present in our HDFS file system. So to do that, we create input directory in HDFS using the command HDFS DFS hyphen mkdir, that is make directory. I'll create it in root only. So okay, this should create. Okay, so it says connection refused error. So just a second. So whenever you get a connection refused error, as I have told in previous video, you should, it's probably some problem with your Hadoop system. So you need to format your name node. So the solution for this is stop all your Hadoop daemons. So once all the daemons are stopped, we have to format the name node. So to do that, we have to use the command Hadoop name node hyphen format. So this will format your name node. So again start all the daemons. So now that your daemons are running, let's try to make the directory again using the same command as earlier. So as you can see, this time we don't have any error. So it has been created successfully. Now we need to create an input text file. So to do that, I'll just use the cat command. So cat say input.txt. Okay, so jar tar rat rat tar jar. Okay. Okay, so we have our input file. But this input file which I created, this is there in our Ubuntu file system. So, which is the local file system. So we need to copy this particular file to our HDFS file system. So to do that, we use the command hdfs, sorry, dfs hyphen copy from local, that is copy from local file system, the file name which is input.txt to the input directory. So that. So now we have to check if our input.txt is present in our input directory. So to do that, we use the ls command. So hyphen ls slash ip. So as you can see, our input.txt is present in the input directory or in the HDFS file system. So now to run our count program, we must use the command Hadoop jar, the location of your jar file which we created earlier, which for in my case I had saved it under home slash Eclipse workspace. So then the second argument needs to be Jagat, which is the name of your project, dot word count, which is the name of the class inside the uh, project. And the third argument is the input directory, which in our case was slash IP, and the output directory name, which you can give anything actually. So I'll just give, say, output. So now we execute this. Okay, since my code was using some outdated functions, I had to do slight changes to my code. So now I have done the same command by changing my code and exporting my jar file again in the same location. So now as you can see, this time our MapReduce program has been executed successfully. And as mentioned earlier, our output file should be present in the specified directory over here, which is slash op. So now we will check our output. So let's see what is the content of our output directory. So you can see that there is this particular file over here. So first let's see what was the content of our input file. So this was our input file. Now let us see what is the output of our MapReduce. So to see the output, we again use the cat command, but this time under HDFS. DFS fin cat. Yeah, slash o. You can just copy this location. Okay, so as you can see, bat 2, because bat I have written 1 and 2 times, Batman 2 times because I've written Batman 2 times, and so on. It has outputted the word count of each word. So this is the word and this is the count, how many times the word is occurring. So that's all for this video. Thank you for watching. I will be putting the updated code in the description, so please use that code when you're executing for yourself.